Maintenance electricians are involved in a wide spectrum of electrical tasks. Their work spans from high-voltage transmission systems to low-voltage control circuits, demanding a broad understanding of electrical principles and practices. They are not limited to one specific area. Maintenance electricians frequently work with high-voltage equipment. This includes transformers, switchgear, and transmission lines operating at voltages of 34.5 kV, 345 kV, and even higher. They ensure the reliable operation of power distribution systems. Their responsibilities include inspecting, testing, and maintaining these critical components to prevent failures and ensure safety. When working with high-voltage equipment, maintenance electricians must adhere to strict safety protocols. These protocols are in place to mitigate the risk of electrical shock and arc flash. This involves wearing appropriate personal protective equipment, such as insulated gloves and arc flash suits. It also includes implementing lockout-tagout procedures to de-energize equipment before performing any work. Maintenance electricians also deal with low-voltage systems. This includes lighting, control circuits, and power supplies operating at voltages of 120 volts, 240 volts, and lower. They troubleshoot and repair these systems to maintain the functionality of various equipment and facilities. Maintenance electricians need a strong understanding of electrical circuits and control systems. This includes the ability to read and interpret electrical schematics, troubleshoot complex circuits, and use test equipment such as multimeters and oscilloscopes. They must also be familiar with different types of electrical components. This includes resistors, capacitors, inductors, diodes, transistors, and integrated circuits. In addition to electrical work, maintenance electricians may also be involved in mechanical maintenance tasks. This includes repairing and maintaining motors, pumps, and other mechanical equipment that is integrated with electrical systems. They may also perform preventative maintenance tasks such as lubricating bearings, tightening bolts, and inspecting belts and pulleys. They also work in various settings, including power plants, water treatment facilities, steel mills, and manufacturing plants. Each environment presents unique challenges and requires specific knowledge and skills. For example, maintenance electricians working in power plants must be familiar with the operation of generators, turbines, and boilers. Those working in water treatment facilities must understand the control systems used to regulate water flow and chemical treatment processes. In steel mills, they work on equipment used to melt, shape, and process steel, including arc furnaces, rolling mills, and continuous casters. A deep understanding of the National Electrical Code, or NEC, is essential for maintenance electricians. The NEC provides guidelines for safe electrical installations and maintenance practices. Maintenance electricians must be familiar with the NEC requirements for wiring methods, overcurrent protection, grounding, and bonding. They must also be able to interpret the NEC to ensure that their work complies with applicable regulations. Troubleshooting is a critical skill for maintenance electricians. They must be able to diagnose electrical problems quickly and efficiently to minimize downtime and ensure the safe operation of equipment. This requires a systematic approach to problem solving, including gathering information, analyzing symptoms, and testing components. They must also be able to use a variety of tools and techniques to identify and isolate faults, such as visual inspection, voltage testing, and continuity testing. Maintenance electricians must also be proficient in using electrical test equipment. This includes multimeters, which are used to measure voltage, current, and resistance. It also includes clamp-on ammeters, which are used to measure current without interrupting the circuit. Other common test equipment includes insulation resistance testers, also known as megometers or megas, which are used to measure the insulation resistance of wires and cables. Power quality analyzers are used to measure voltage harmonics and other power quality issues. Furthermore, maintenance electricians are involved in the installation of new electrical equipment and systems. This includes running conduit, pulling wire, terminating cables, and connecting equipment to power sources. They must be able to follow electrical blueprints and schematics to ensure that the installation is done correctly. They must also be familiar with different types of wiring methods. This includes rigid conduit, electrical metallic tubing, flexible metal conduit, and cable tray. Safety is paramount in all electrical work. Maintenance electricians must be aware of the hazards associated with electricity and follow safe work practices to prevent accidents and injuries. This includes wearing appropriate personal protective equipment, using insulated tools, and following lockout-tagout procedures. They must also be trained in first aid and cardiopulmonary resuscitation, or CPR, in case of electrical shock or other emergencies. The role of a maintenance electrician requires a diverse skill set. It includes a strong understanding of electrical principles, hands-on experience with electrical equipment, and the ability to troubleshoot and repair electrical problems. They must also be familiar with safety regulations and codes and able to work independently and as part of a team. Continuing education and training are essential for maintenance electricians to stay up to date with new technologies and best practices. This includes attending workshops, seminars, and online courses. It also includes reading trade publications and participating in professional organizations. By continuously learning and improving their skills, maintenance electricians can ensure that they are providing the highest level of service and expertise. When working on a 480-volt motor circuit, for example, the maintenance electrician would need to verify that the disconnect is properly locked out and tied out to prevent accidental energization. They would then use a multimeter to verify that there is no voltage present on the circuit before beginning any work. The electrician would then inspect the motor windings for any signs of damage or overheating. They would use an insulation resistance tester to measure the insulation resistance of the motor windings to ensure that they are within acceptable limits. If the motor windings are found to be faulty, the electrician would replace the motor with a new one. When installing the new motor, the electrician would carefully follow the manufacturer's instructions and ensure that all connections are properly tightened. They would also verify that the motor is properly grounded to prevent electrical shock hazards. After the motor is installed, the electrician would test it to ensure that it is operating correctly. This would include measuring the voltage and current of the motor to ensure that it is within the specified limits. It would also include verifying that the motor is running smoothly and without any excessive vibration. When working on a 120-volt lighting circuit, the maintenance electrician would need to identify the circuit breaker that controls the circuit. They would then turn off the circuit breaker and verify that there is no voltage present on the circuit before beginning any work. The electrician would then inspect the wiring and fixtures for any signs of damage or wear. They would replace any damaged or worn components such as light bulbs, sockets, and switches. When replacing wiring, the electrician would use the correct size and type of wire for the application. They would also ensure that all connections are properly made and that the wiring is properly supported. After the repairs are completed, the electrician would turn on the circuit breaker and test the circuit to ensure that it is operating correctly. Maintenance electricians may work in locations with potentially explosive atmospheres like chemical plants. They need to be familiar with explosion-proof equipment and wiring methods that are designed to prevent explosions. This equipment is designed to contain any sparks or arcs that may occur within the enclosure, preventing them from igniting the surrounding atmosphere. Maintenance electricians must also follow strict procedures for working in hazardous locations. This includes obtaining permits, using calibrated test equipment, and wearing appropriate personal protective equipment. They must also be trained in the proper use of explosion-proof equipment and wiring methods. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Bonding connects all metal parts of an electrical system together, creating a low impedance path for fault current. Maintenance electricians must understand the principles of grounding and bonding and ensure that all electrical systems are properly grounded and bonded. They must also inspect grounding and bonding systems regularly to ensure that they are in good condition. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Maintenance electricians must understand how these devices work and ensure that they are properly sized for the application. They must also test overcurrent protection devices regularly to ensure that they are operating correctly. It is crucial to understand the different types of electrical drawings and diagrams. Single-line diagrams, or SLDs, are simplified representations of electrical systems that show the major components and connections. Wiring diagrams show the detailed wiring connections between different components. Schematic diagrams use symbols to represent electrical components and their functions. Maintenance electricians must be able to read and interpret these diagrams to troubleshoot and repair electrical problems. Electrical systems often include control panels that contain various control devices such as relays, timers, and programmable logic controllers, or PLCs. Maintenance electricians must be able to troubleshoot and repair these control panels to ensure that the electrical system is operating correctly. They must also be familiar with the programming and operation of PLC. Motors are a critical component of many electrical systems. Maintenance electricians must be able to troubleshoot and repair motors. They also perform preventative maintenance tasks such as lubricating bearings and checking for proper alignment. They must also be familiar with different types of motor starters and control circuits. Variable frequency drives, or VFDs, are used to control the speed of motors. Maintenance electricians must be able to troubleshoot and repair variable frequency drives. They must also be familiar with the programming and operation of variable frequency drives. Power quality refers to the characteristics of the voltage and current in an electrical system. Poor power quality can cause equipment to malfunction or fail. Maintenance electricians must be able to identify and correct power quality problems such as voltage sags, voltage swells, and harmonics. They may use power quality analyzers to measure and analyze power quality parameters. Thermal imaging is a technique that uses infrared cameras to detect heat patterns in electrical equipment. Maintenance electricians can use thermal imaging to identify hotspots that may indicate potential problems such as loose connections, overloaded circuits, or failing components. Cable testing is essential to ensure the integrity of electrical cables. Maintenance electricians use various cable testing methods such as insulation resistance testing and time domain reflectometry, or TDR, to identify cable faults. High potential testing, also known as HIPOT testing, is used to verify the insulation strength of electrical equipment. Maintenance electricians use HIPOT testers to apply a high voltage to the equipment and measure the leakage current. This test can detect insulation weaknesses that may not be apparent under normal operating conditions. Battery maintenance is crucial for backup power systems. Maintenance electricians must inspect batteries regularly, clean terminals, and test battery voltage and specific gravity. They may also use battery chargers and analyzers to maintain battery health and performance. Transformers are essential components of electrical power distribution systems. Maintenance electricians perform regular maintenance on transformers, such as checking oil levels, inspecting bushings, and testing insulation resistance. They may also use transformer oil testing to assess the condition of the transformer oil. Arc flash is a dangerous electrical hazard that can cause severe burns and injuries. Maintenance electricians must be aware of the dangers of arc flash and follow safe work practices to prevent arc flash incidents. This includes wearing appropriate personal protective equipment, performing arc flash hazard assessments, and using arc flash mitigation techniques. Lockout-tagout, or LOTO, is a safety procedure used to de-energize equipment before performing maintenance or repair work. Maintenance electricians must follow lockout-tagout procedures to ensure that equipment is properly de-energized and that it cannot be accidentally energized while work is being performed. Confined space entry is a hazardous activity that requires special training and precautions. Maintenance electricians may need to enter confined spaces to perform maintenance or repair work. They must follow confined space entry procedures to ensure that the space is safe to enter and that they are properly protected from hazards such as toxic gases and oxygen deficiency. Working at heights is another hazardous activity that requires special training and precautions. Maintenance electricians may need to work at heights to access electrical equipment. They must follow fall protection procedures to prevent falls and injuries. Electrical safety audits are conducted to identify potential electrical hazards and ensure that electrical systems are in compliance with safety regulations. Maintenance electricians may participate in electrical safety audits and implement corrective actions to address any identified hazards. Electrical training is essential for maintenance electricians to stay up to date with new technologies and best practices. Maintenance electricians should participate in regular electrical training courses to enhance their knowledge and skills. Documentation is crucial for electrical maintenance. Maintenance electricians should maintain accurate records of all maintenance and repair work performed, including dates, descriptions of work performed, and parts replaced. These records can be used to track equipment performance, identify trends, and plan future maintenance activities. Predictive maintenance techniques are used to anticipate equipment failures and prevent unplanned downtime. Maintenance electricians may use predictive maintenance techniques, such as vibration analysis, infrared thermography, and oil analysis to monitor equipment condition and identify potential problems before they occur. When troubleshooting a motor control circuit, a systematic approach is necessary. Firstly, verify the incoming voltage to the control panel. Secondly, check the control transformer output voltage. Thirdly, inspect the overload relay for tripped contacts. Fourthly, examine the motor starter coil for continuity. Fifthly, test the stop and start push buttons for proper operation. Sixthly, review the motor wiring connections. Seventhly, measure the voltage at the motor terminals. Eighthly, analyze the motor current draw. Ninthly, inspect the motor for overheating. Tenthly, replace any faulty components as needed.